We're going to transition to our next topic, and our next speaker is Brian Killingsworth. Brian is Executive Vice President of Local Paving for the National Ready Mix Concrete Association. Brian provides technical support and education to member companies, to affiliate associations, contractors, and local owners regarding concrete pavements. Prior to joining NRMCA, Brian was a consultant for 20 years. And conducted work with both concrete and asphalt pavements. It should be also noted, as Eric mentioned, that Brian was instrumental in pavementdesigner.org as well, so he is well versed in a number of areas, and we are very, very happy to have Brian Killingsworth joining us now to talk about designing and constructing resilient, sustainable pavements. So with that, please welcome Brian Killingsworth.
Thank you, Art. I appreciate that introduction. Got my screen shared, and I think hopefully everybody should be able to see it. So we are going to talk a little bit about how we design and construct resilient and sustainable pavements. Before we get to that, though, we really need to kind of define what does it mean to be resilient and what does it mean to be sustainable. So first thing we want to look at is resilience, and that's the ability to resist, absorb, accommodate, adapt to, transform, and recover from the effects of a hazard in a timely and efficient manner. And that can apply to a lot of different things, a system, a community, or to a society. So it's kind of a very broad-based definition. If we want to get it to something that's a little more in line with what we're talking about today, we're talking about transportation systems and pavements. That definition from the FHWA would be the ability to anticipate, prepare for, and adapt to changing conditions, and withstand, respond to, and recover rapidly from those disruptions. So that really, in a nutshell, is kind of what resilience is. And it's, you have a disaster of some sort, a hazard of some sort, and then you respond to that, and how quickly you respond to that really kind of defines how resilient that asset or that structure is. So that's resilience. When we talk about sustainability, we're talking about the pavement's ability to achieve some sort of a goal, an engineering goal for what it was constructed for. And hopefully what we can do is preserve and maybe even restore some of our surrounding ecosystems through the construction of that pavement. And then we're also going to use our financial, human, and environmental resources economically. That's the kind of that triple bottom line that we talk about, the social, economic, and environmental. And we also want to make sure that we meet basic human needs, such as the health, safety, equity, employment, comfort, and happiness. So that's kind of what I'm going to claim sustainability is. Now, when we talk about sustainability, we're talking about a kind of broad impacts. We tend to think about sustainability in terms of our greenhouse gas emissions, right? So we think of it here. We tend to think of CO2 equivalent or carbon burden, that type of thing. What does our infrastructure, our pavement, how does that impact us environmentally? And we tend to always think about greenhouse gases, but there's a lot of other things that sustainability can mean in terms of how much energy consumption, or am I saving energy in some way with that asset? Does it impact habitat and water quality, or that hydrologic cycle of rain absorption, evaporation, that type of thing? Am I impacting air quality or the mobility, the community mobility by adding a pavement or adding a lane? That access to the rest of the community, how we move freight, all of that type of thing can also be an impact when we talk about sustainability. So just kind of keep that in mind as we go through. Now, the one thing that I want to make clear is that sustainability and resiliency are not the same thing. They can be compatible, but they're not necessarily equal. And what does that mean? Well, remember we said resilience is that ability to respond to some sort of a hazard or a natural disaster. we can build a pavement that is very resilient, but it may not necessarily be very sustainable. So we need to understand that they can kind of co-live together, sustainability and resiliency. But just because we build something sustainably does not mean it's resilient, and vice versa. When we build something resilient, it's not necessarily sustainable. So those two things are different, can be different. They can, again, they can be compatible with one another, but one doesn't mean the other is going to occur. So let's talk about resilience a little bit. Again, get a little bit deeper into what it means, but also when we're talking about how do we design and construct resilient pavements. So again, resilience is that ability to anticipate, prepare for, and adapt, and then withstand, respond, and recover. So if we have some sort of an event that occurs right here, we will lose performance, right? So we'll lose the ability for that asset, for that infrastructure, for that pavement to perform adequately. So there will be some sort of a recovery time, and then we'll kind of be back either near or at or near our performance, or maybe be even above our performance prior to, sorry about that, prior to that hazard or event happening. So what this green line shows here, it shows that it is more, this asset is more resilient than, say, what happened here, because it took longer to recover, and we did not recover up to the performance that we had prior to the event. The green shows, well, we in fact recovered quickly and we're at that same performance. Now, we can actually build structures to where they will rapidly recover, and maybe even by what we do during that recovery period, they may be even better in terms of performance than they were before. And when we talk about an event, what we're talking about is something like flooding, maybe wildfire, earthquake, that type of thing. And we'll talk about that just a little bit more here. So when we're talking about impacts to pavement, climate impacts, what do those impacts entail? That can entail temperatures. What we're seeing with climate change is higher average temperature, higher extreme maximum temperatures, warmer extreme minimum temperatures. So we're not getting as cold, severe cold. And then maybe more freeze-thaw events, particularly in areas where we tend to see significant winters. What we may see is more freeze-thaw events that occur in those regions. When we look at precipitation, we may have higher than average precipitation over time, maybe wetter winters, drier summers, low summer humidity, and more extreme rainfall and flooding. We talk about extreme events like droughts, floods, wildfires. What can that do? Well, it can affect subgrade moisture, particularly when we talk about droughts. We can have a decrease. What we may see with flooding is a more frequent roadway inundation. So they're flooded, the substructure of our pavements is flooded. And then with fires, we may see more in terms of frequency, and also larger in terms of size wildfire fires. We've seen that here the last few years. And then we also can maybe have sea level rise, where we see more frequent roadway inundation as well. So what are the impacts to pavements directly? With temperatures, we may see expanding slabs, and we see those blow-ups that we've seen maybe out in the desert west. We may have more significant curling and warping to our pavement, so we have loss of support. We may see our subgrades in our base weakening a little bit. So we have poorer performance with our pavements. We may see subgrade heave more, particularly when we go from drought to very high moisture content in our subgrades. And then also we may see some embankment instability along the sides of our pavements as well. So we have pretty significant impacts from our climate. When we're talking about pavements, the most significant impacts to our pavements, whether they're roadways or airports or intermodal facilities, whatever, we typically are seeing that flooding is our most significant risk to our pavements. Things like tornadoes and wind, drought, heat, wildfires, while they may have some sort of an impact to the pavement, really when we talk about operating cost and the funding gap that we have in terms of keeping our infrastructure at a certain level of performance, flooding really is the big issue, the biggest risk. And there's three different types of flooding. The first would be severe flooding from natural disasters. Think of our eastern coast, think of the Gulf Coast, and particularly Houston. Houston, over the last several years, has had several significant flooding events, the worst being Hurricane Harvey. So we have hurricanes, we get tidal rise, we get significant rain, and we have flooding that can occur, and our pavements can be flooded and inundated for a very, very long time. Sometimes it can be weeks. And when we have that, we have a reduction in strength of our pavement, typically below the surface. Another way flooding can occur is in the plain states. We may see significant river flooding going over the embankments during the snow melt, the springtime. So we can have significant flooding. We tend to see that in these plain states here, where we get overtopping of our river banks and we get the significant flooding. And again, we'll see portions of our roadways that are flooded for a very long time. And then in our coastal zones, with sea level rise, whether it's a permanent rise in sea level or more frequently now, tidal rises, so daily changes in tide can actually flood streets. We see that a lot in Delaware, Florida, a lot of these coastal cities. We'll see this tidal sea level rise that occurs throughout the day. And again, we can have that inundation of the pavement that can cause us problems. So we talked about inundation a little bit. There's actually two different types of flooding that can occur. The first one there on the left is what we call washout. So that's where you get a really rapid flow of water, very high current, and that basically scours away the material below the pavement and eventually into the pavement, and the surface is washed away. Now, the pavement type, whether it is a flexible pavement or a rigid pavement, really has no impact on the ability to resist scour. It's just going to happen. Not much we can do about it in terms of the pavement type. Where pavement type really does make an impact is when we're talking about inundation. Several states, several counties and cities have looked at the difference between the ability of a flexible pavement or a typical asphalt pavement over top of granular material to recover from and perform adequately after inundation. We see a big difference between flexible and rigid pavements. Rigid pavements tend to recover quicker, and we don't see as a significant loss of performance with concrete pavements. So that's a little bit about sustainability, and we'll talk in just a minute about some of the things that we do to design to incorporate sustainability into our designs. We'll talk about that, incorporate resilience into our designs. We'll talk about that in just a moment. So resilience we've talked about. Let's talk about sustainability a little bit. And really, what's important about sustainability is not necessarily that we can design for it, but that's important. But the other part to it is we need to be able to report how sustainable our infrastructure is. And the way that we report, and then also the way that we assess whether we are doing a better job in terms of our sustainability, our environmental impacts. We need to be able to report that adequately and then also be able to determine how much better we are doing. So let's talk about that a little bit. So when we talk about sustainability, there's two things that we need to keep in mind. One is what we call embodied carbon, and the other is operational carbon. So this is the impact that we are going to have with our infrastructure, with our pavement. When we're talking about embodied, what that means is it's the release of CO2 or some other sort of impact, whether it's release of methane, whether it's an impact on our rivers and streams, whether it's air quality, whatever sustainable impact or environmental impact that we're looking at. When we are creating that asset, when we're manufacturing, when we're transporting raw materials to our manufacturing infrastructure, when we are transporting that material to construct that asset, that's what we call embodied carbon. The operational carbon is the energy that is used as we are using that asset. Think of a building, for example. We can build a building and we will have measures of our embodied carbon. And then when we use the building in terms of, think of air conditioning and water use and that type of thing, that's what we would consider our operational impact, or in terms of carbon, our operational carbon. So there's two things that we talk about, and to get a full sense of our life cycle, we have to combine the total embodied carbon with our operational carbon to give us a full accounting of the impact. So what might that look like for a pavement or a building? Well, we start here in terms of extracting raw materials, and when we do that, we have some sort of greenhouse gas emission, and then we have to transport that stuff to the factory. We have to manufacture it. Then we have to transport it to our construction site, construct it. All of that is embodied carbon. When we use our building or our pavement, that's our operational carbon, but there's also embodied carbon that's allocated in the use phase. And then at the end of the life of that infrastructure, we demolish it, we haul it away, and we take it to a landfill. Again, that has embodied carbon as well. So just important to understand those two things when we're talking about environmental burden or impact. Now, when we are talking about sustainability, there's a couple of different things that we can do. This is kind of that reporting portion that I was talking about. One is we can simply disclose to somebody, a buyer or an owner or a government, whatever the case may be, what our environmental impact is. So we would be disclosing, the impact that we have. The other is we want to be able to look at our infrastructure and compare different types of materials and say, all right, well, this one does a better job in terms of environmental impact than this material does, or this pavement structure does. And so that would be comparing. We utilize what we call environmental product declarations to do that disclosure. And basically what all that means is that owner, that buyer, they want to look at kind of across the board when they build that infrastructure, what is my environmental impact going to be? And I can ask each person that manufactures for that pavement, for that building, to tell me, to disclose to me what that environmental burden is. When we actually want to make decisions, we have to do what's called a life cycle assessment. And that incorporates the entire life cycle. When we're disclosing, what that can mean is we're only taking and disclosing a certain portion of our environmental impact. And I'll show that on the graphic here in just a minute. But when we actually want to compare and make a decision on which material is better, that's when we use the full life cycle assessment. That's called cradle to grave. So when we are doing a material disclosure and an environmental product declaration, what we're typically looking at is just cradle to gate. And what that kind of looks like is a food label. So on a food label, it tells you what's all my vitamins and minerals that are on here, and then also what are my impacts in terms of fats and sugars and things like that. And so a environmental product declaration, or an EPD, would do basically the same thing. What it's going to tell you is, kind of the energy that's required to make that material, and then what those operational impacts are. So we get an operational and an environmental impact that's reported out. Okay, and again, that's from cradle to gate. So we can use those EPDs in a few different ways, and how well those things are verified is what gives us the validity of that EPD. So what does that mean? Well, there's a couple of different ways we can develop an EPD. There's this option 1 and option 2. In option 1, what we're doing is we can report 3 different ways. One way we can report is just for the manufacturer of that material to just kind of self-declare and say, all right, this is my environmental impact. Nobody checks his numbers. Nobody does any kind of validity check. Nobody really looks at and verifies whether things are correct. It's just somebody stating it, and that owner then must kind of take their word for it. We can go to the next level, where what we may do is say, all right, if I'm going to produce concrete to build a pavement, I can look at all of the different concretes that I might use to build that pavement, with 3,500 PSI with straight cement, or 3,500 PSI that maybe has, 60% cement and 30% of our fly ash in it, okay? And I can report that. I can get all of that data. I can, work the numbers. I can have somebody that verifies it. And we can generate EPDs that are called an industry average for each of those performance levels, that 3,500 with the different types of materials and a 4,000 with the different types of cements and materials. And I can use that to report to an owner. So that's a next level better. The other is to say, all right, for this particular job, I'm going to use this mix from this producer. And that producer is going to provide a product-specific EPD that is also verified. All of his numbers are verified. Everything that he did in that process to determine that environmental impact is going to be verified. All right, so that's one way we can disclose. The other way that we can disclose is by saying, you know what? I'm going to show you how much better I am than the average, the industry average, or some other type of material. So I can utilize the EPD to demonstrate how I reduce my environmental impact from some other level, some benchmark that is set, or from the industry average. So we can use EPDs a lot of different ways, but primarily all we're doing there is disclosing. When we talk about cradle to gate, what we're talking about is the location at which we stop our accounting of our environmental impact. So you can see here, we have our production stage, our construction stage, use, and end of life. An EPD typically just kind of covers this portion, the cradle to the gate. So cradle being pulling that material that we need from the ground, essentially. So we're extracting our resources, we are manufacturing it, and then we're getting it as far as to the construction site. And that's all that we're accounting for in terms of our environmental impact. All this other stuff we're not accounting for in terms of our environmental impact. It's just that kind of early portion of the manufacturing stage. So if we want to be able to incorporate all those other stages, the construction, the use phase, the end of life phase, we have to incorporate what we call life cycle thinking. And we know this already because we do this in the pavement arena in our life cycle cost analyses. But simply all life cycle thinking is to reduce a product's resource use and the emissions to the environment, as well as improve its socioeconomic performance through its life cycle. So that extraction of raw materials all the way through that life cycle to the end of its use. And again, we do that a lot with life cycle cost analysis. We look at things like our initial cost. What does it cost us to maintain it, rehab it? What's it cost our users when we're using that pavement? And then what is our residual value of that pavement at the end of its life? So we do that in life cycle cost analysis and kind of evaluate our economic considerations. So it's an accounting, right? So we're doing financial accounting there. Same type of thing when we do environmental considerations. Basically, all we're doing is accounting for that environmental impact at the resource extraction, the processing, the placement, the use, the maintenance and rehab, and at the end of life, what do we do with that asset or structure? Do we recycle it? Do we leave it in place? You know, what's the benefit if there is a benefit at the end? So in here, instead of accounting financially, what we're doing is accounting for our environmental impact, typically, which is greenhouse gas emissions. So that would be here, okay, those greenhouse gas emissions. But there are a lot of other impact categories that we can look at. You know, what is our energy used to manufacture and use that asset? Resource use. What's the toxicity to my environment by building that resource and using that resource, that asset? Okay, so just like with the EPDs, we're reporting typically our greenhouse gas emissions. We do that same thing in terms of our life cycle assessments, but we just have to understand that there are a lot of other impacts that we actually can report. The next thing to think about when we talk about making decisions, using that life cycle assessment to make a decision, the question is, within that process of building our asset, when do we make a decision about what's best in terms of our environmental impact? So do we do that in the pre-design stage, in the design stage, during procurement, construction, or the use phase? So it's important for us to be able to recognize we're going to make a decision based on our environmental impact at a certain point in our construction process or in building that asset. Typically, when we are doing, say, life cycle cost analysis, we typically do those during the design stage. Okay, and we can do a life cycle assessment at the design stage as well. We just have to understand that we can make those decisions at different times within that whole kind of procurement process, the pre-design, design, the actual procurement and contracting, constructing and using. We have the opportunity to do those life cycle assessments at all these different points. The other thing that's also important to understand is what criteria are we going to use, who does the analysis, and can we really compare results? Because that becomes important. Many times if we do an LCA that has different boundary conditions, we can't compare LCAs of differing types of materials. So if our boundary conditions are different in terms of our manufacturing, for example, between concrete and something else, then we cannot really make a decision about which one is better in terms of its environmental impact, because we're comparing apples to oranges, not apples to apples or oranges to oranges. So it's important to understand what those boundary conditions are and whether or not they're the same for those materials and whether we can compare. So we see that here. You know, many times what we want to do is choose a sustainability winner, right? what we want to say is design A wins over design B, C, or D. Okay, and that's not really the best way to utilize either an EPD or an LCA. All right, what we typically want to do is choose the material that we're going to use because it's the most materially efficient. And then what we do is optimize and economize that design so that we are reducing that kind of environmental impact of that material. Okay, so it's difficult to make material choices utilizing an EPD and an LCA. All right, so that's very quickly an overview, not very quickly, but it's an overview of resilience and sustainability. Let's talk a little bit about how then we can utilize materials and designs and asset management, things like that in terms of incorporating green elements. We know that we can utilize low impact materials to achieve some of our sustainability goals and some of our resiliency goals. There's many ways that we can do that, and I'll just touch on a few. One would be utilizing something called Portland limestone cement. We know that cement and the manufacture of cement has an impact on our environment. It's a fairly intensive CO2 manufacturing material. And if we can reduce the impact by utilizing what's called a Portland limestone cement, then that's a great option for us. And what that is a blended cement that has additional limestone content, and it's optimized for whatever performance it's going to be used for. It's a really easy way to reduce your carbon footprint by about 10%. And it can be used in buildings, bridges, pavements, geotechnical applications like stabilization of soils and things like that. And PLCs are readily available throughout the US and Canada. So you can get them from your cement suppliers fairly easily. And we can demonstrate this. So if we were to look at several different concretes, for example, one just being an average 3000 PSI concrete, straight cement, nothing else, no fly ash or slag in it, we would see our global warming potential of about this. If we use some fly ash, we can see it go down a little bit. If we use some more slag, we can see it go down even more. If we were to take and utilize a Portland limestone cement in lieu of just the Portland cement, we would get about another 10% additional decrease at each one of these levels. Okay, so PLCs are a great way to be able to lower impacts in our concrete for either pavements or for buildings. Another thing that we can do is use a different type of cement. One, it's a cement where we are utilizing the benefits of what's called carbonation. So one thing we can do is in terms of manufacturing, we can change the way that we manufacture our cement a little bit by adding CO2 actually into our manufacturing process. Okay, and so when we inject CO2 into that cement manufacturing process, we can actually cause that CO2 to chemically react, and it allows us to use less limestone in our manufacture of cement. We can use lower kiln temperatures in the manufacture of our cement. So we produce about 30% less greenhouse gases. So we're actually taking captured carbon and utilizing that in our manufacture of cement. We can do the same thing in the manufacture of some of our aggregates. Okay, so we can take captured carbon from some other industrial manufacturing. We can capture that carbon and we can inject that or sequester that into some aggregates. Okay, And so we can sequester CO2 by kind of changing the aggregate, if you will. So it's another way in which we can lower our impact is by using captured carbon in our aggregate development. And then another one that we can do is right during the midst of our concrete manufacturing. So at a ready mix plant, we can actually inject CO2 into that manufacturing process. And it creates an artificial limestone as it goes through a reaction. As you're mixing your cement, your water, your aggregates, you inject that CO2, and then it sequesters that CO2 within the concrete. It enhances the compressive strength a little bit, and it also reduces the cement content. So there's some significant benefits through this enhanced carbonation or this injection of CO2 at different points into the concrete manufacturing process. And then, of course, most people know about pervious concrete. This is what we'd consider a sustainable material because it's an open graded system and allows water to flow through it. And when we allow water to flow through it as runoff from rain, it actually kind of cleans that water before it hits the water table. So we're reducing our total suspended solids, reducing our metals like zincs and irons and things like that, and also nutrients from runoff that comes from fertilizers and things. We're kind of capturing all of that stuff here, retaining it here, and by the time the water hits the water table, it's clean. So a lot of different ways in which we can impact our pavements in terms of our environmental impact just by using low impact materials. And we can also use recycled materials and things like that. So there's a lot of ways that we can impact our environmental burden. Let's talk about things that we might do to lower the environmental impact during the design stage, and then also how we might improve resilience. One way that we can do that is just changing the way that we do pavement design. Eric did a great job taking us through the pavementdesigner.org. So he gave us kind of an overview of how we might do a pavement design. And typically what we do in pavement design now is this. We say, all right, I'm going to start out with my climate, my soil conditions, my traffic, my concrete strength, right? And I'm going to evaluate that against some performance target. And, the performance targets that Eric was talking about was fatigue life and erosion and faulting. Okay, so we look at a set of pavement layers and thicknesses, and we analyze whether or not it meets our performance requirements, that 15% slabs cracked, or that we want to be below a ½ inch of faulting. All right, and we kind of go through an iteration process to tell us how thick our pavement needs to be. Once we do that, then we develop what's called these life cycle bill of activities. So that would be all of that cost data and all of that environmental data that we would need to do our life cycle cost analysis and our life cycle assessment. So we're basically doing this LCCA and LCA once. We do the iteration to make sure that we get the right cross-section, but we only evaluate its life cycle impacts once. We can actually change that process to where we incorporate the LCCA and LCA in optimizing our pavement design for economics and for environmental impacts. So what we would do here is we would say, all right, we're going to start out with some inputs. We'll evaluate those inputs, develop those life cycle bill of activities, apply all of our cost and all of our environmental data, and then evaluate it in terms of our life cycle cost criteria and our life cycle assessment, our environmental criteria. So we establish those criteria and we say, well, does it meet that performance or does it not? If it doesn't, then we go back up and we change our pavement structure and maybe the materials that we use to where you can finally kind of iterate on what would be our most economic and our most environmentally impactful pavement design. So if we change that methodology a little bit, we can be a little bit more impactful in the design stage and make sure that we are reducing our burden both economically and environmentally. So if we do that, what we find is that, let's say we just did a couple of things. You know, maybe we used recycled materials, or we just went from, you know, 2 rehabilitation cycles to 3 rehabilitation cycles. We can see we wouldn't have a really significant impact in our environmental burden. If we optimize here in terms of that process I just showed, it shows that we could potentially have very, very significant environmental and economic reduction, burden reduction. So represents a real clear win-win situation if we change just that methodology a little bit. One thing I talked about was that washout versus inundation, and what we showed, or what research has been showing, is that just simply by adopting a hard, stiff surface, i.e. concrete, we can produce more resilient and potentially more sustainable pavement cross sections. One city that has kind of applied all of that knowledge is Riviera Beach in Florida. They're one of these that tends to have a lot of coastal flooding that can occur from either hurricanes or from tidal changes. And they went through a very significant rebuild of some of their sewer and water utilities and things like that. And they went from an asphalt surface road to a concrete surface road because they were finding that their concrete surface roads and other portions of their city were actually performing much, much better, even when they got flooded. So if we can just simply start by using concrete, that helps in terms of resiliency and potentially sustainability. Now, in terms of designing for resilience, one of the things that we can also do is base our designs on the weakest subgrade condition. So think about a subgrade when it is completely saturated. It has a significant amount of water and moisture in it. Generally, if it's a clay subgrade or silt subgrade, we'll see very, very significant loss in strength. And so if we simply design for a very weak subgrade, we can help make that pavement cross-section more resilient. We'll make it more resilient. It may not necessarily be the most sustainable pavement design because it may require more materials. So you might have to do a little bit more optimization to make it sustainable as well, even if we are making it more resilient. So this is a case in which we say we can make something more resilient, but not necessarily more sustainable. All right, so that's the design phase where we can impact sustainable or resilient. So let's look at the asset management stage, or what we would call the use stage, or maybe the maintenance and rehabilitation stage. A lot of different ways that we can talk about it. But in terms of asset management, what we do is we take, over time, we kind of take snapshots of how well that infrastructure is performing, whether it's lighting or signage or traffic control devices or drainage structures, roads, bridges, whatever the case may be. What we're really interested in is how can we impact things from a roads standpoint during our asset management decision-making stages. So when we're talking about pavements, asset management is really what we capture in terms of our pavement management systems. So what we do is we gather a bunch of data about our pavement structures, right? The thickness, how well they're performing, how long they've been there, the maintenance and rehab cycles that we have performed. We capture all of that data, and then we segment it based on our network. And we get kind of a state of the network. We get a current state of the network, and we can produce reports, we can produce performance histories and things like that. So all of that data in our pavement management system can then help us decide what are the maintenance and rehabilitation strategies that I need to apply to my network to make it economical and sustainable. So essentially what we do is we take all of that data that we've gathered, we evaluate it, and we kind of predict what our performance is going to be going forward. All right, and then we make decisions about what are the best treatments that I can apply to my pavement so it'll perform adequately over time. And so we kind of optimize that. You know, is an overlay the best idea? Is crack sealing the best idea? Is concrete pavement rehabilitation through grinding the best idea? So we kind of select the treatments and determine when those things need to be applied. Now, how can we make that more sustainable? What we can do is do LCAs during that decision-making phase. So when we're trying to decide what's that best maintenance or rehabilitation technique, we can then incorporate those life cycle thoughts about the materials and what the environmental impact would be in that decision-making stage. So what might that look like? Okay, so here again is our pavement management system up here, and we're going to evaluate certain treatments based on what our pavement management system tells us. So what we would do is then conduct that for each treatment. We would conduct that LCA, and it would tell us what our greenhouse gas emissions would be. And we can get a full accounting of what our life cycle would be on the environmental side. And then we can also do a full accounting of what our life cycle cost would be for the economic side. And then we can make a decision about what the best treatments are and when, based upon kind of optimizing for the environment and for our economic considerations. Other things that we can do during that use phase is, you know, we talked about all these different types of treatments. Well, we can apply things like concrete overlays. They can be sustainable, and they can also help us in the resiliency side. So how would that occur? Well, if we have just a flexible pavement right here and we load it, we know that that stress is applied all the way through that pavement. So let's say during a rain event or a flooding event, what tends to happen is these layers right here can become very, very weak. And so what we tend to see is an increase in distresses that can occur when these layers are inundated and weak, because all of that stress is being carried in those weak layers. If we add a concrete surface to that flexible pavement, essentially what we're doing is moving that stress burden up here into the areas of the pavement that are hardened, that basically can handle all of that stress. And when all of this down here is wet, it doesn't have that much of an impact. So we can recover quicker and we can perform better and achieve that performance quicker. So concrete overlays are great because they can be sustainable and they can be resilient. We'll talk about concrete overlays in just a minute, but basically all you're doing with overlays is you're preparing that surface, cleaning it, you put the concrete right on top of it, you texture it, you cure it, and then you joint it. So a very simple process that we'll get into a little bit more detail, I think, in the next segment. Another thing that we can do is what's called full depth reclamation. When we do full depth reclamation, essentially what we're doing is changing again these weaker layers into something that's a bound layer that's stronger. And so if this does get wet, this would weaken. If this got wet, it wouldn't weaken as much. Okay, and so that's whether it's water coming up from the bottom or water coming from the top. And again, all we're doing here is we're taking the existing asphalt pavement and granular base, we're pulverizing it, adding some sort of stabilizer to it, and then we put a new surface on top of it. So again, that's something that can be done during the use phase, the rehab phase. And then the very last thing that we'll talk about is when we do make our pavement stiffer, we actually reduce pavement deflection and pavement roughness. All right, so when we reduce deflection, make things smoother, when we actually traverse the pavement, we can use less fuel, and if we use less fuel, we can have a lower environmental impact. So using stiffer materials can help us, and that can help us not just on a single project, but if we apply that over our entire network, we can lower our environmental burden as well, and potentially also be more resilient. So in summary, we talked about resiliency and sustainability are good. They're compatible generally, but not always equal. We can disclose or quantify sustainability different ways. And then we can also become more resilient and sustainable at different stages within our life cycle. So Art, that concludes it for me. Hopefully, yeah, just a couple minutes over. I guess we'll defer questions until later so we can get to the next one.
You know, I think we do have perhaps time for just a couple of questions. I know I ran long with my opening announcements. One written in here, Brian, that says, can weigh-in motion scales be installed in a concrete surface, and how much is the calibration impacted by air temperature?
Yeah, so that's a good question. Yes, weigh-in motion can be installed. You know, there are different ways you can do that. You know, some that are just directly on the surface, others that have to go into the pavement itself. You know, I don't know enough about those weigh-in motions to understand how much temperature would affect it. You know, generally what we see is a little bit lower temperature in lighter surfaced materials. So you can anticipate with concrete that you'll have lower surface temperatures. So that may prove beneficial, but I can't speak to how significant that would be. Okay.
And that's something too that we can maybe follow up on at a later time too, and get back to this individual. I had just two things I wanted to point out. You know, great presentation, and I appreciate you being here and going through all of this information with us, Brian. You covered a lot of ground today. And I really like the, you know, section on the life cycle thinking. I think that's a very critical component that, you know, we all are guilty of maybe not putting as much stake in, and that's something that, you know, should receive additional consideration. You mentioned that it can be done at any stage during the planning cycle. Is there one, in your opinion, that you think stands out better, you know, a stage where it really should happen? You know, granted, you can always go back and do it, but in your thought process, what gives you the most bang for your buck?
Yeah, so there's, you know, it really depends on what the desired outcome is. What it comes down to me is when we have the most information that's available to us to make the best decision. Sometimes we want to push that life cycle analysis very, very early into the process. If you do that too early, so, you know, maybe even in the pre-design stage, if you do that too early, you just don't know enough to be able to make an adequate, meaningful decision. So generally, we want to be at the point, at the project level, where we know about our project, we know, you know, some information about our subsurface and our environmental conditions, and we have sufficient data to be able to understand what the impact would be over the life cycle. So, you know, generally that's going to be in that procurement stage, design and procurement stage, that typically is where you have sufficient information to be able to make a meaningful decision about what pavement system is going to give you the biggest bang for the buck.
Right. Yeah, thanks for answering that, Brian. There's a couple of other things, but I will, in the interest of time, we can follow up with those questions offline. I do want to take, before we transition to our final speaker, just a couple of minutes to also put a plug in for the Pave Ahead program through the National Ready Mix Association, which you are responsible for. A number of people on this call are familiar with this. We've utilized it in North Dakota to help design parking lots or review jointing plans. But could you give us maybe a 1-minute overview of what this service is, and how the people on this call can really take advantage of it? And there's a theme here as well. Pavementdesigner.org we don't charge for. Maybe let us know what your fees are for Pave Ahead as well, Brian.
Sure. So the Pave Ahead program was developed to help users, to help owners, those types of folks that they know that pavement is an important asset. It's an asset that can potentially be expensive. But not everybody is familiar with how you really truly need to design a pavement so that you are economical and that you are addressing environmental concerns. And so what we did was kind of develop this Pave Ahead program to give some resources to those people, and also to provide some services in terms of designing, helping in designing, assisting in designing. And so you can go to the Pave Ahead website, and you can look through our resources, you can look through all of our education information. But if you really want some help in terms of getting an optimized design and understand how it's going to impact economically or environmentally, you go to that Design Center button, press that button, put in your information, and it will shoot an email to me. And I'll either contact you or somebody on my team will contact you. We'll help you through that process. And as Art mentioned, that process is at no cost. What we want to do is be able to support you, help you, and make things as easy as possible for you. We don't want to burden you with a fee to do that. Now, what that means though is we're not going to sign and seal plans, designs, that kind of thing. We'll give you all the information you need to go to your engineer and say, here's what I think is important. Go through this information and get some help from the Pave Ahead team if you need it. But we're here to support. We want to do that as easily as possible.
All right. Well, thank you, Brian, and really do appreciate you taking the time today. I know that we could spend a lot more time visiting about these topics, but we need to move on. So